and error like I did here to help you out. You have your focal point here. That's what we did with our last lab. We found the focal points, which is kind of a cool thing to do. Our center of curvature is right here. Now what I'm going to do is I'm going to do number one right here. I'm going to draw a light ray parallel to the principal axis. Anytime the focal point and the center of curvature will always, always, always be on the principal axis. Okay? So I'm going to do this. I'm going to draw this parallel to this line right here to the best of my ability. Okay? So I'm going to do this and draw a parallel. Okay? And this marker is not good for video taping. A better one of each. These are new. Okay, so I draw that parallel. Then what it says is is reflected through the focal point. So what's going to happen here is that this is going to go right through that focal point. And if you did your diagram pretty decent the other day, you noticed this. So that's going to go through here. Okay? So that's my incident ray. If I wanted to do this, I could. That's my incident ray. That's my reflected ray. Right there. Okay? That's number one. Done. One is done. Number two, any light ray drawn through the focal point reflects back parallel to the principal axis. Okay? So what I'm going to do now is I'm going to go through the focal point right here. I'm going to go from here to here, right through that focal point, right there. Okay? Then, that's going to come back parallel to the principal axis. Hopefully we all remember what the heck parallel means. Okay? I can hit you. So yes, I probably should say it on camera. Joke? Camera? Alright. So, number two is done. So now, the last one. Any light ray drawn to the vertex. So since some of you have protractors, you can do this very accurately. But check this out. The vertex is at that one spot right there. Because remember, this is actually a, let's say it's a concave or a convex mirror. It should be a concave. So it actually would look like this. Right? That's what the mirror should actually look like. But drawing a curve with that is not easy. Okay? So what I'm going to do is I'm going to draw to the vertex from here. Notice these are all at the very tip. Okay, these are all at the very tip. Boom. And if that is at that one point with the principal axis, there is no angle of incidence, and well, the angle of incidence, the angle of reflection is what? At the principal axis. Do you remember? Does it bounce straight back? At the principal axis?
Yeah.
So what's my angle of incidence and angle of reflection? Nothing or zero. The absence of something. Right? So what I want to notice, guys, if I took my protractor here and I measured the distance right there, it would be the exact same on the other side. Okay? So what I'm just going to eyeball it. You have protractors. It should be, this looks pretty good actually. If you notice something here, guys, okay? Those two angles should be congruent to the law of
Geometry.
begins with an R. Reflection. Reflection, very good. So, notice, all of these meet right here. So my rays of reflection are doing what? They are coming together. What's the word for coming together? Converging. So now check this out, guys. So, if I look at this, now, check it out. All these lines are from the very top, right? So now there's my image right there. Now the question is, Sal, what do you think? Is this a real or a virtual image?
Real.
Good, that's right. Now, why is it a real image, Gio? Why? Somebody said it at the table, I think. The lines are converging, right? So this is a real image, it's inverted, and it's smaller. Right? Because this is my object right here. This is my image that's going to show up. Okay? And what you're going to do this one's object beyond C. So here's C, I'm beyond it. The next time you're going to do this is going to be at C, right here. And you're going to do it at different spots. Okay? That's exactly how you do that. And I'm telling you right now, on your quiz, there will be a constructive response like this. Okay?